Welcome back, physical science students. We hope you enjoyed your break and that it was restful, and that we're ready to tackle another semester of physical science. So everything we did last semester was part of chemistry, and the good news is we can leave that all behind, and because this semester we're focusing on the branch of science called physics. Now we're not going into as much detail as a physics class, but we're still going to talk about the same uh, topics. The first one we always talk about first in physics is motion, and specifically, how do we describe motion? So to begin, we're going to first talk about how do I look at motion happening and how can I graph that? And then as we go through this first week in the second semester, we're going to talk about, okay, if I can graph motion, what does that graph tell me? Or what information can I gather from that graph? So first, let's look at some motion. We've got a ping pong ball cannon here. So I'm just going to play it first. We'll see what it does. It shoots the ping pong ball and slices right through that Coke can. So let's start that over. Now there is some parts of this video that are before the launch. Let's look at right when the launch happens. So let's right when the ball comes out of the cannon. So right there. So how can I describe this motion? Well, we're going to make something called a position graph, and I'm going to need two things for that. I'm going to need, first of all, the time and the position. So where is the ball? That's what position is. And then at what time is it at that position? Or at what time is it at its location currently? So to figure out position, I kind of need to put, some measurement tool on here. So let's put a ruler. This ruler is in centimeters. And let's go ahead and start that right where the ball is at this moment. So the ball starts at 0 centimeters. If I do a stopwatch, let's say we're going to set this as our 0. So our problem here, what we're trying to describe, is starting at this specific moment in time. So we're going to set that as our 0. So my time is 0 seconds, my position is 0 seconds. I'm going to go ahead and put that over in my table. So my time and position are both 0. Now my table, this S stands for seconds, this cm for centimeters, so I already know what these numbers, what their units are, what it's measured in. This means 0 seconds, this means 0 centimeters. When I put it in the top of the table like this, it allows me to not have to write cm after every single number. I just automatically know that number is in centimeters. So let's keep going. Let's find some more data points here. If I go, let's just take the stopwatch off. Let's say I go forward 1 frame, and let's say that took a second. If that took a second, how far did the front of that ball travel, or where's the front of that ball now after 1 second? Well, its position now looks to be about this line right here, which, if this is 10, each one of these individual lines is 1 centimeter. So this has gone about 8 centimeters. Now, when you're filling this table in, you can either do it like I am on your own Google Doc, or what I would actually prefer is if you could print this out, if you can, print this out and actually physically write this. It might be very helpful when we actually start graphing this. Just might make it easier on you. If you wanted to completely write this over on your own, you could do that too. As for me in this video, I'm going to be doing this all virtually, so I'll have to edit this drawing, and we'll see after we get our time and position values how I do that. So let's keep going. 1 more second. After 1 more second, it's at this line right here, which that's 10. This semi-longer line is 15. That's going to be about 16 centimeters. So at 2 seconds, it's at 16 centimeters. All right. 3 seconds. It's gone up to about this line. And I know it's in between it, but I'm just going to guess here that, or round to this number, or this line here, which is going to be 24 centimeters. So at 3, it's at 24. Now 4 seconds. That looks to be past 31, so we'll say it's 32 centimeters. And then after 5 seconds, that's right at about 39, I would say. Then after 6 seconds, that looks to be about 47. So I'm just getting positions at each of these times. As time progresses, its position changes. That's what we're graphing here. Now, at 7 seconds, it's hit the can. We're going to stop now. It looks like the right edge is past 54, so let's say it's about 55. So at 7 seconds, it's 55. Now, once it hits the can, there's some other things in play that we'll get to later this semester, but let's stop our description or observation here. So we only have 7 data points. That's fine. We might not have all 10 of these filled out, but that's okay. So let's look at how do I use this to fill out my graph here, or how do I use that to graph? So let me just do a quick snip here. I'll see if this works. I double click on the graph and it brings up this drawing if I'm on a computer. Now what I'm going to do here, you don't have to do this, is I'm going to put my table over here just so I can see what I'm actually trying to graph. And then once I've graphed it, I'm going to take that away. So for my data points, I'll use tiny circles here. And I'll make them black, and I'll make them red. Okay, my first data point is at 0, 0. So I'm going to graph it there. First of all, let's look at our scales here in our graph. On the x-axis, which is the horizontal, my 5 seconds is right here, 10 seconds is right here. If I know that my labels are 5 and 10, what does that mean each of these boxes is worth? Well, if it took 5 boxes to get to 5 seconds, each of these boxes is 1 second. So every moment of time, these all increase by 1. At 1 second, I'm going to graph 8 on this part of the line. So I'll go up to wherever 8 is. So on the y-axis, if it takes 1, 2, 3, 4, 5 boxes to get to 30, well, I'm going to divide 30 by 5 to tell me what each of these boxes is worth. That means if it takes 5 boxes to get to 30, each of these is worth 6. So that means the first one is 6, the second one's 18, the next one's 24. Nope, my bad, sorry. First one's 6, second one's 12, then 18, then 24, then 30. So I have to keep that in mind when I'm looking at my numbers over here. Okay, well, if this third line is 18 and I want to graph 20, well, it should be slightly above that, but not to the next line because that was going to be 24. So somewhere in between 18 and 24 is where I would put that if that's what I was graphing. So let's keep going here. I'm going to make another one of these dots. At 1 second, it is about 8. So this first one is 6, the second one's 12, so somewhere in between there is going to be 8. And I'm going to say it's around right there. Then at 2 seconds, it's 16. So I've got 6, 12, 18. Gone too far. A little bit below 18 is where 16 probably is. Another one. So at 3 seconds, I've got 6, 12, 18, 24. So that's nice and easy because the line lines up with my point. Let's do another one. At 4 seconds, 32. So 6, 12, 18, 24, 30. 6 more would be 36, but I only want 32. So that's somewhere in between 30 and 36, like there. Then at 5 seconds, it's 39. So this is 30, 36, 6 more is 42. So it's in between these two lines. Let's say it's about right there. Let's go to our next point. So at 6 seconds, it is 47. So let's see, we've got 30, 36, 42, then 48. 47 is slightly below 48, so about right there. Then at 7 seconds, it's at 55. So if this line we just said was 48, 48 plus 6 is 54. 55 is slightly above 54, so we'll put it there. All right, so I've got my points. They more or less make a straight line. They may not be perfect, but that's okay. What I'm going to do, though, is actually make a straight line through these points, if at all possible. I need to move this edge of the line a little bit. There we go, to about right there. So that's what our graph looks like. It is increasing. It is more or less a straight line. So we'll talk about what does it mean that it's a straight line. What does it mean that this graph is going up? Some more tomorrow. But for now, this is how we're going to graph. So let's do this a couple more times and get some different types of graphs, just so we can see what's going on here. All right, so now let's look at another situation. I'm going to go a little bit faster here, getting my points for my table. So this is our rolling ball 1. This ball, I'll play it for you once, rolls to the right, and so I'll reset that. And let's just go through these frames. So I've got a stopwatch here, which is going to give me my time, and we're going to get the position from this ruler here on the video. So let's go forward to 0.1 seconds. So at 0.1 seconds, if each of these lines is a centimeter, it looks to be right at about almost 4 centimeters there. So if I'm at my table, notice again, when the time was 0 seconds, the bowling ball started at 0 centimeters. When the time was 0.1 seconds, we just said it was at 4 centimeters. So let's keep going. Let's go to 0.2 seconds. At 0.2 seconds, the right edge of the ball looks to be somewhere around 8 centimeters. Now let's go to 0.3 seconds. That looks to be somewhere around almost 13 centimeters. So 0.3, 13, 0.4 seconds. That looks to be around 17 centimeters. Oh, let me change this. So at 0.4, that's around 17 centimeters. 0.5, that's around 22 centimeters. Then 0.6, oops, back one. That's going to be about 27 centimeters. And again, I'm looking at the right edge of the bowling ball here. So at 0.7 seconds, that looks to be almost 30, that's about 31 centimeters. 2 more, 0.8 is about 36, 0.8, 36 centimeters. And then finally 0.9, where's it there? At 0.9 seconds, it looks to be about 40 centimeters. So again, let's take this data and let's graph it. So I'm going to double click on the graph again if you're doing this virtually. Over here to the right, I will put my data table and let's start plotting some points. Nope, let's delete that. All right, so I'll make my point like that. I'll put the first one at 0, 0. And now we'll see what the graph looks like all filled in so you can check yourself. So here we have our completed graph, our dots plotted, our line drawn because it looks more or less like a straight line again. Notice when you're plotting points here, each one of these boxes on the x-axis on the horizontal is 0.1 seconds, because if it takes 5 boxes to get to 0.5, that means each one of these is 0.1, 0.2, 0.3, 0.4, 0.5, then 0.6, 0.7, 0.8, 0.9, and all the way to 1. Now on the y-axis, with position, if it takes 5 boxes to get to 25 centimeters, that means each of these boxes is worth 5. So I go 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. I keep that in mind when I'm plotting these times on the x-axis and these positions on the y-axis, and that leads us to this graph. All right, let's keep going. I'm going to try to speed this up a little bit. Let's start with 0, 0. At time 0, it's at position 0. Let's go to 0.1 seconds. 0.1 seconds, oh look at that, that's 10 centimeters. 0.1, 10 centimeters. Let's go another 0.1. It is now at 23. So 0.2, 23 centimeters. That's 0.3. It is now at 35. 0.3, 35 centimeters. Let's see if we can go to 0.4. It is now at like 48. 0.4, 48. Does it go to 0.5? It does. At 0.5, we are now at 60. And let's see how far we can go. It stops at 0.53. So we'll just keep this data table as is. I'm going to get data points for another scenario. That'll be our last one. And then I'll show you what the graphs for both of these look like so we can check ourselves. All right, so now looking at this motion, my time is at 0. So we're going to start at 0 time again, because we're always going to go forward in time. But what is its starting position at 0? It's no longer 0 because my ruler is set this way, where positive numbers go in a positive direction to the right. So this is starting out at a position of 100 centimeters. After 0.1 seconds, where is it? After 0.1 seconds, it looks to be about 91 centimeters. Its position anyway. So it went from 100 to 91. Then after another 0.1 seconds at 0.2, it looks to be about 82 as far as where it is on the ruler. Another 0.1 seconds, it looks to be about 73. So 0.3 seconds, it's at 73. At 0.4 seconds, it is at 64. At 0.5 seconds, it is at 55. Just going to keep going until it stops us. At 0.6 seconds, it is at 45. So 0.6, 45. 0.7, it is at 36. Can we get to 0.8? No, we can't. That's where we'll stop. So we'll stop there. Okay, let's go back to our graphs here. I'll make this bigger or full screen. So let's look at this first one. I'll copy my table so I know what I'm graphing. I'll double click on my graph. I will paste my table here to the right. And so now I've got my table, I've got my graph. This is what your graph should look like with all plots, with all your points plotted and the line drawn. And here we are. So on this graph, you may have noticed that this last point here, the 0.5 and 60 centimeters, actually didn't fit. So I just left that I left that point out. But these are our 5 points from 0 to 0.4 and from 0 to 48. Again, each of the boxes right to left is 0.1 seconds. Each of the boxes up is 5 centimeters. So I keep that in mind when I'm figuring out where do I plot these points. And then I kind of draw a line that goes through the average of all the points, because more or less it looks like it's a straight line yet again. All right, so let's go to our last graph here. And finally, here's our last graph. Notice that this graph starts at 0, 100 because my position was not 0 to begin with. My position was 100 based on the ruler I had on the video. And what that position did was that position went down as time increased. So it gives me a graph that is still a straight line. And again, we're going to talk about the importance later. But now the graph slopes downward. So that means a certain thing about its motion, which we'll cover tomorrow. But today, the point is, can I look at a situation, can I get data, and can I graph an object's position as time increases? So hopefully through these 4 graphs we can do that. Tomorrow we're going to talk about, okay, now what does this mean? I can graph it, but what types of information can I get from this graph? So I hope this video was helpful, and we'll see you tomorrow.